to the basic concepts of GPR, how it works, and how to interpret the data as displayed on its output. GPR stands for Ground Penetrating Radar. It is an electromagnetic signal that penetrates to the subsurface. GPR systems are typically comprised of three elements: the control unit, the antenna, and the survey encoder. Depending upon your application, your GPR system may differ from the one illustrated in the video. For example, this handheld GPR contains all three components in one dedicated system. The antenna has a transmitter and a receiver. When the signals are returned to the antenna, we record a two-way travel time and the amplitude of the signal. The amplitude is simply the strength of the signal coming back. Antennas come in various frequencies depending upon your application. High frequencies are for shallow depth and small targets, ideally for concrete applications, while low frequencies are for deeper depth and larger targets, such as utility, geological, and archaeological applications. Survey area with high conductivity and limit in the depth of effectiveness of ground-penetrating radar. An example of this would be clay soils or uncured or green concrete. Here is an example of objects or targets underground and how the data will be displayed in the real time. As you collect the data, note the hyperbolas or upside-down U-shapes when targets are crossed at 90 degrees, and when you back the antenna up, a cursor would appear on your screen. By bisecting the hyperbola with the cursor, this would mark the horizontal location of the target. Radar travels at different speeds through different mediums. A value is assigned to these mediums to represent different velocities of radar. These values are called dielectric. Dielectric is important so that the depth of targets or layers can be accurately estimated.
Air has a dielectric of 1, which means radar travels fastest through air. Water has a dielectric of 81, which means radar travels slowest in water. Every medium in the world falls somewhere in between. Lastly, remember that GPR is electromagnetic energy. Other sources of electromagnetic energy, such as cell phone towers and two-way radios, may interfere. This will not cause any damage, but may make it more difficult to see deeply into concrete or soil. In addition, unlike X-ray or other technologies, ground-penetrating radar is not harmful and has no site restrictions associated with use. This brings us to the conclusion of theory and fundamentals of ground-penetrating radar. Ground-penetrating radar, or GPR, is a geophysical technique that can be used in archaeology and geology to conduct non-invasive site investigation. GPR can be used to quickly map a site for excavation or to quickly locate potential cultural resources in a way that minimally impacts the site. This allows archaeologists to target areas with buried anomalies, which reduces the time and cost of sampling and excavating. GPR collects and records information about the site's subsurface by mapping physical or chemical changes in the ground. This can include fossils, architectural components, or even areas where archaeologists have excavated previously. In the earth sciences, such as geology, ground-penetrating radar is used to study bedrock, soils, groundwater, and even ice. Ground-penetrating radars are also used by scientists. As shown in the video, geologists scan the area for potential sinkholes before it could be deemed safe for use.